Greetings, Mr. Kolazar's class. So to continue on with our chemical reaction types, we're going to now look at double replacement reactions or double displacement reactions. So as we're going, both of those terms can be used interchangeably. But what we're going to look at is when ions exchange between two aqueous ionic compounds. So we need to have two compounds to begin with. So we'll always have a precipitate or a solid produced, water or a gas. One of these three things will always be produced when we have a double replacement reaction. Solubility tables we're going to check out in just a second. That's on page 1 of your gold packet. Make sure you put page 1 down instead of 3 to find out if it's aqueous or if a solid is being produced. Now our general reaction equation, plus and minus from ionic compounds, plus minus, the positive and the negative parts are going to go together, and the negative and the positive parts are going to go together. So the positive is going to connect up, and the positive of the second one is going to connect with the negative of the first one. So the ions are exchanging places. Our solubility table, found on page 1 of your gold packet, lists out a couple important things. First off, we're going to see if things are soluble or an aqueous in solution, or insoluble, meaning a solid precipitate will form. So first chart has our soluble compounds. Our soluble compounds, as we're going, are going to be anybody that's in group 1, like sodium, lithium, potassium, etc., ammonia, our nitrates, acetates, carbonates, chlorates, perchlorates, all of our halides, group 17, except when they're combined with lead, silver, or mercury. So these are the exceptions. The exceptions would mean that these would be solids, or a precipitate would be formed. Sulfates, SO4s, are all are soluble except when they're combined with sodium, strontium, barium, lead, or silver. And again, that would be they would be also forming solids when those combined. Just the opposite, insoluble compounds. All of our carbonates, chromates, phosphates, sulfides, and hydroxides are insoluble except when they're combined with group 1 or NH4. And then when we get to hydroxides, calcium, barium, strontium are the exceptions. The exceptions would mean instead of being insoluble, that they would be soluble. So being able to use this chart is going to help us out as we're going forward to decide our products if they're going to be soluble or insoluble. So to look at this, predict the products that will be formed, and then will a precipitate form. So zinc sulfate plus ammonium sulfide, again zinc, positive 2, sulfate from gold packet -2, ammonium's a +1, and sulfide's a -2. Now zinc sulfate, if we go back to our chart, we need to find the sulfates. Let's see. Sulfates, all SO4s, except when we're combined with these elements. We don't have that one, so they are all soluble. And then NH4, all ammonium are soluble. So using that chart, you can find out both of our reactants are aqueous to begin with. Now the positive of one is going to connect with the negative of the next. So zinc, Zn is a +2, sulfur is a -2, so our formula is ZnS. And then our second one, our positive NH4, +1, is going to react with SO4 is -2. So when they react, we need 2 NH4s in order to balance out the one negative SO4. So NH4 taken twice, SO4. Now all of our sulfides are insoluble except if they combine with group 1 or NH4. So zinc sulfide is going to be our solid, and NH4, all ammonia, as we talked about earlier, are automatically aqueous. So right now our precipitate to form is going to be our zinc sulfide. To see if we're balanced, if we look at both sides of our reaction, comparing our zincs, our SO4 stick together, our NH4 stuck together, and our sulfurs, if we were to look, we have one zinc on each side, we have one SO4 on each side, 2 NH4s on each side, and 1 sulfur. So in the end, we're balanced to begin with already. And then will our precipitate form? Zinc sulfate will be that precipitate. So the solid that's formed during that reaction. In our second one, we've got aluminum hydroxide plus hydrochloric acid HCl is going to produce two new compounds, so we know double replacement. Aluminum is a +3, hydroxide's a -1, hydrogen's a plus, chlorine's a minus. So what we're going to look at is aluminum and chlorine are combined, hydrogen and the hydroxide are going to combine. So aluminum hydroxide, as we're looking through our hydroxides, combined with group 1. So as we're going, aluminum hydroxide is going to start out as a solid. All of our chlorides are aqueous, unless combined with silver or mercury or lead. So as aqueous to begin with. Now what we're going to form, aluminum's a +3, going to combine it with the -1 of chlorine. So AlCl3 is our first compound, and hydrogen is going to combine with the OH negative to form HOH. Now all chlorides, bring your gold packet, let's see, all halides, all chlorides, except for silver, lead, or mercury, are going to be our aqueous. And our second one, HOH, fancy way to write water, is going to be our liquid. So as we're going, liquids are going to be one of the ways, or precipitates or gas that we'll always have during a double replacement reaction. And then to balance her out, aluminums, we have 1 on each side. OHs, we have 3 and 1. Chlorines, 1 and 3. And finally hydrogens, 1 and 1. So as we're going, in order to balance this one, if we have 3 OHs on this side, we need 3 OHs on this side. So 3 times hydrogen gets us to 3, gets us to 3, and then as we're looking, in order for it to finish out the balancing, we need 3 in front here, gets us to 3 chlorines and 3 hydrogens. So in the end, both sides same number of atoms, so as we're going, balanced chemical equation. And our last problem to deal with, double replacement reaction, predict the products of the following reaction, and then will a precipitate form. So silver nitrate and sodium chromate solutions are mixed together. So silver chromate, silver's a +1, nitrate's a minus, sodium is a plus, and chromate is a -2. Chromate Cr2O4, sodium's Na, nitrate NO3, and silver is Ag. So to begin with, silver nitrate NaNO3 plus sodium chromate, sodium's a +1, so Na2 Cr2O4 is going to produce. Now all nitrates are soluble from our chart, all nitrates, and then from there, second one, all group 1 elements are also soluble. So as we're going to form, silver's our plus, is going to combine with chromate or minus. Silver's a +1, so Ag2 Cr2O4, and we're going to add to that sodium, our positive ion, is going to connect with nitrate NO3 -1 and NaNO3 are minus. So to look at our two products, all group 1, so sodium is soluble and nitrates are soluble, and then all of our chromates are insoluble, so, except with group 1, so nope, we're okay there. So silver chromate is going to be our solid formed, and silver nitrate or sodium nitrate will be our aqueous, AQ there. So as we're going, sodium chromate was aqueous also. So as we're going, what we're looking at is our precipitate formed, silver chromate, And to finish out, balancing chemical equation, 2 sodiums on one side, so we need to put a 2 in front here, 2 nitrates on this side, NaNO3, 2 in front here, gives our 2 nitrates, Ag2, and we have 2 there, so to make our balanced chemical equation, 2 silver nitrates aqueous plus sodium chromate aqueous is going to produce 1 silver chromate plus 2 sodium nitrates. That again is our double replacement reactions, 2 compound switching places.